Hello, we're going to dive into the next question. This is on separation technique. This is usually our second chapter that we'll be introducing in year 9. So we're going to follow the sequence, so it won't be too difficult for you. Alright, so 7 marks, let's dive in. So with this question first, what we have is a series of separation technique, and it's in the box over here, isn't it? Chromatography, you should know this are linked to this technique is linked to ink or dyes. Crystallization, it's when you want to obtain crystals, of course, all right, and this would be like from salt solution. Common example would be to obtain like sodium chloride from seawater, or like not seawater. Seawater is impure, from salt solution. Okay, and then you have the two different distillation. The main difference between them, simple and fractional distillation, is that fractional distillation, you want to obtain 2 or more liquid or solvent, if I can be more precise, and these 2 solvent have different boiling point. Okay, again, if I can give you a specific example, it will be ethanol, a mixture of ethanol and water, because pure ethanol boils at 78 degrees Celsius, whereas pure water boils at 100 degrees Celsius. Okay, so with that, let's look into the question. You see that for part 1, we're trying to get a single food dye from a mixture, and every time you have like dye or food ink, for example, then you will use chromatography. Next, we'll try to separate gasoline from crude oil. Might be a little bit difficult for some of you who have not been introduced to organic chem. So organic 1 will introduce this idea. So crude oil is basically our black gold, okay, something that we extract from under the seabed. But from crude oil, we would be able to just take away this, okay? If not, it looks like root oil. Okay, so from crude oil, we can actually extract a few fractions. Gasoline is just one of them. The more common things that students are familiar with will be petrol or diesel. Sorry, DIESEL. Okay, and these are just different example of fractions that we can extract from crude oil, because these different fractions, diesel, petrol, and gasoline, for example, they have different boiling point, so we can use fractional distillation to extract them. And finally, we have one more example. We want to get water from copper sulfate solution, taking note that we would only want one type of solvent. Okay, so we just want the water from this salt solution, so we use simple distillation. Alright, next one for B. This represents a molecule. There are many types of molecule out there. It's not always 2, but you also have like common example like water, H2O, or even carbon dioxide. These are molecules. Okay, what is the opposite of molecules? Essentially atom. Atom is just one circle on its own, like helium, but molecule, you can just visualize 2 or more circles coming together. Okay, but for this question, they want you to explain why this molecule is a compound. So what is a compound in the first place? Compound must be made of 2 different elements. So in this case, I can only think of like at the back of my head, I just thinking of carbon monoxide, CO, right? It's made of 2 different elements, and they are chemically bonded together. So just hitting these words alone, you will have the keywords and the key points to get our 2 marks. But I just want to take a moment to extend a little bit. Now, what does this chemically bonded together means? It's actually between the atoms. So this is atom number 1, the yellow, and then atom number 2 is the red one. So what is keeping them together is this bond that is between them. This is what I mean by chemically bonded together between the atoms. This is what makes a compound. A compound will always have fixed number of elements or atoms of elements. Say for example, carbon dioxide is always going to be 1 carbon and 2 oxygen. Okay, this number is always fixed. For water, it's going to be 2 hydrogen and 1 oxygen. Okay, and what is keeping this entire thing together is the chemical bond between the oxygen and the hydrogen. Okay, so it is not the same as saying they are chemically bonded together between the molecules. Between the molecules, say for example, we just stick to water. Okay, what is essentially between the molecules is not chemical bonding, but this is just weak intermolecular forces. Okay, so take note of the difference. If you extend your answers and they say are chemically bonded together, and this chemical bond is happening between the molecules, you won't get marks for compound. Okay, all right. So part C needs us to look at this really lengthy compound formula, and they are looking for what is a different number of elements. Now, to look for this answer, you are essentially looking for the uppercase alphabet. Okay, why? Because if you refer to a periodic table, if you have one nearby, please refer to it. You will see that every element is represented by an uppercase. So there are certain elements that has 2 alphabets, like calcium, but the second alphabet will always be a lowercase, or like even silicon. What else do we have? Astatine. Yeah, the second alphabet will always be a lowercase. So here you see that there are 4 main types of elements because they are all represented in uppercase. So the answer would be 4. Next, we want to look into the number of atoms in this molecule. Okay, so how do we do that? Basically just add things up. So here we've got 3 for carbon, 5 hydrogen, 3 nitrogen, and then 9 oxygen. Adding them up here will give us 20 in total. Okay, so that's all for the 7-mark question. It's not entirely really difficult, but it would serve as a foundation for you to start collecting your marks before you reach the harder question. Okay, so if this is all good, I'll look into question 7 and see you on the other side.